Hello and welcome. This is Baraner Avila reporting for multiplexer and demultiplexer. So what is a multiplexer? Multiplexer was invented by Jean-Maurice Emile Baudot and evidently developed the concept of division multiplexing, which is in turn makes the future of communications. So what is a multiplexer? Multiplexer transmits large numbers of information channels to a number of channels, selects binary information from one of the many input channels, and transmit to a single output line. It is also called as a data selector. Two n input channels can be controlled by n numbers of selector line. Input line is selected according to the bit combinations of select line. It is having a select line. So we will be doing a 2-to-1 multiplexer. So here is a truth table for a 2-to-1 multiplexer, and here is the schematic diagram. But first, let me just do it. So there we go. As we can see, if the selector is inputs, both of the inputs is 0, it has an output of 0. If the input 1 is having an input of 1, the output is also 0. If input 0 is having an input of 1, the output is 1. So as we can see here, we have concluded that if the selector is, it just selects the input of I0. If both is 1, the output is also 1. But what happens if selector is having an input? Both of inputs having an input, so it has no output. But if I1 is having an input of 1, the output is 1. So evidently S0 selects I1. But if I0 is open, we can see that it has no input, and if both of the inputs having an input, output is 1. So all of these components is inside this MUX multiplexer. So let's also try this truth table on this. If I1 is having an input of 1, so take note that if selector is 0, it just selects I0, and both of the inputs is 1. There we go. And if selector is having input of 1, it just selects I1. Okay. So there we go. Now we're going to a 1-bit selector. So any 1-bit selector, the input is coming from the XNOR. So using also this truth table, we will be using the take note that this is selector, this is I0, and this is input 1. You can see that there's no input when all of the pins is 0, but if I1, there we go. In a 1-bit selector, we can say that the output is only coming from the OR gates. Here. But it just simultaneously, not at the same time. Here. Now, here, the input is going to an OR gate. So we can conclude that only simultaneously the I0 and I1 is going through the XNOR when it is open. But if both of it is open, it's going to OR gate. So there we go. Now if all of the pins is open, there is no output. So here's a 3-bit selector. So in the 3-bit selector, you have a multiplexer and a number of gates. You have an AND gate, an OR gate, a NAND gate, an NOR gate, an XOR gate, and an XNOR gate. I also have a arithmetic gates and of addition. Now we're going to the multiplexer. The multiplexer is also invented by Jean-Maurice Emile Baudot. The multiplexer is used to connect a single source of multiple destinations to main application area. The application area of the multiplexer communication system where multiplexer are used. It's designed to switch one common input line to one of the several output lines. It's also known as a data distributor. Takes one single input data line and then switches it to any of a number of individual output lines one at a time. Function is to switch one common data input line to any one of the 4 output data lines. So here is a truth table for a demultiplexer, and we will be making it. So if this is just connect because it's hard to make it from scratch. So and Bandicam has only a 10-minute restriction, so it's only for free. So if we have an input data of D, so this is the essentially D is 1, so here, and this is the just maximize. This is the inputs, and this is the outputs. So there we go. Let me just try it. If all of the SO is having an input of 0, then the output is on Y0. Take note, this is Y0, Y1, Y2, and Y3. If S1, S0 is having an input of 1, you can see that Y1 is open. So if S1 is having input, there we go. Y2 is having an output, and if both is open, then Y3 is having an output. So we can see that they are linearly related. The output of the data. So I hope you have learned something on my video, and thank you for listening. Again, this is Brian Avila reporting for multiplexers and the multiplexers.